will have no units because ever K partition will never have any units because the concentration in the numerator cancels with that in the denominator. So we are left with only a value. So to three significant figures, the K partition in this case is 0.0789. Now what this tells us about the value of K partition, what it tells us about hexane and methanol is that Q is much more soluble in methanol than in hexane, because if you see the denominator value is greater than the numerator value, and that's why K partition is less than 1. So Q is more soluble in methanol compared to hexane. Now let's do another example. The partition coefficient of organic compound H between dichloromethane and water is 4.75. So dichloromethane and water, so the K partition, we will write the first one in the numerator and the second one in the denominator. So K partition is equal to H in, I'm taking dichloromethane as D, H in D over H in aqueous phase because water. So H aqueous. So this is the formula for the partition coefficient. Now we know that this is equal to 4.75. So what we do is that now they say that 2.5 grams of compound H was dissolved in water and made up to 100 centimeter cube in a volumetric flask. So the total initial amount is 2.5 grams. So 50 centimeter cube of this aqueous solution was shaken with 10 centimeter cube of dichloromethane. So if there was 2.5 grams in 100 centimeter cube, then there will be 1.25 grams in 50 centimeter cube, because obviously the concentration is constant. So we have 1.25 grams, which is the total initial amount, because we have only used half of this solution, which is given in the first bullet point. We have only used half of it. So 1.25 grams in 50 centimeter cube, and this was shaken with 10 centimeter cube of dichloromethane. So if I say that an amount X was extracted into the dichloromethane, so I say that X was extracted, X over 10, because X grams were extracted into the 10 centimeter cube of dichloromethane. This will be divided by 1.25 minus X over 50, because the amount was extracted from this 1.25 grams, so we will have to subtract X, and this is for water. So this is the amount of dichloromethane of H in water. So 1.25 minus X in 50 grams in 50 centimeter cube of water. So when I calculate X, I'm not doing the entire calculation, you can do it on your own, but when I do this on the calculator, X turns out to be 0.609 grams. This means that 0.609 grams of X was extracted into dichloromethane from water. So of H. So 0.609 grams of H was extracted from into dichloromethane from water. So we are done with partition coefficient as well. So this is the end of the topic. We have completed further aspects of equilibria. We have done acid-base equilibria and solubility. So we have covered a lot, and you can do some practice papers, some past papers from the link I've given in the description, gcguide.org, or you can mail your doubts to me at alevelchemistryfree@gmail.com, which is also given in the description. So see you in the next playlist.